Good evening, my dear lovely warriors. This is your Captain Shreyas on the one and only Unacademy NEET English channel. Welcome aboard to the NEET Conquer series with me, your captain. How are you all? Hello, Jasper. Hello, Jyoti. Hello, Muthuchandran, Sangeeta. Nice to see all of you back on the channel. Now, let me clarify because many students. Just one second. Oops. Wow, looks like a disco song. Okay, no time to dance, time to study. Okay, so some students were confused. Sir, is this chapter deleted? Is this chapter reduced? Sir, why are you conducting this chapter? I'll tell you everything about it. But before that, have you smashed the like button? If you have not done that, please do it right away, right now. Very important, go ahead, smash the like button and subscribe to the channel so that you do not miss any updates. Whatever latest information was even given by NMC, I came on the channel, gave it to you. No rumors, no random nonsense, to the point facts, so that you guys are not confused. You are very clear in your mind, right? Okay, so talking about what about center of mass, sir? Is it deleted or not? What do you guys think? Have you read the notification carefully? Have you read the syllabus carefully or not? Center of mass, is it there or is it not there? Well, if it was not there, why would I come over here and waste my time and teach you, right? Good evening, Vedanjani. Nice to see all of you. Hello, Subhashni. Hello, Senthil Kumar. Siva Kumar. Hello. Veena. Hello, Austin. Hi, Siva Prasad. Hello, Subhashni. Hello, Mishra. Thank you, Balaji. Thank you so much. Balaji, I have taken your name. Yes, Satyam. It is there in the syllabus. Yes, Sangeeta. I know you are dependent on me, and I will make sure that that dependence turns into my responsibility and that translates into your score and your marks. So guys, I'll tell you what is there and what is not there very, very clearly. So in center of mass, finding center of mass is there, and center of mass of different bodies. Center of mass of different bodies is there. That's all. Okay. What is not there, because you will see some part is missing, that is your motion of center of mass. Motion of center of mass is not there. Not just that, even your Newton's law of motion for system of particles, that is also not to be seen in the actual syllabus, right? So only these two small things are there. So we are going to focus only on these. Yep. Thank you, Siva Prasad. Hello, Shimi Deva. Yes, am I audible properly? Oh, looks like my mic fell down. Yeah. This is a class 11 chapter, BTS Army, right? This is a class 11 chapter. Cool. So shall we begin with only these two things? I feel that since the syllabus is so less, you should complete it, because if one question comes, you will feel bad that, arey, only finding center of mass only. I left that. I could have done it within few hours. So I don't want you to feel bad. That one mark might change your life. That one mark might decide whether you are in the government college or not, right? So let's complete that. It will not take much of our time. Let's start with it. So what is the meaning of center of mass? See, it's where you can assume the point, or where you can assume the mass to be concentrated as a point. Let's say, for example, everybody has had idli, right? It looks something like this from the side, right? Something like this, like a spaceship, right? This is your idli. Awesome. So this idli is made of many particles, many particles. If I apply some force, if I throw it in the air, you don't like the idli. It's horrible idli. It tastes like rubber. It's like rubber. Okay. You throw that idli in air. Okay. It goes like this, like this, like this, like this. This particle is going like this. This particle is going like this. You know? This particle might go like this. So every particle is going in different parts, but there is one point in that idli. Which is going like your normal projectile motion. That one point is where the entire mass of the idli can be assumed to be concentrated. That is the center of mass. It will go like, your normal trajectory.
Like if you take a particle and throw it at an angle, projectile motion, parabolic motion, motion under gravity, exactly like that. That means it feels as if this idli's mass was concentrated over there. Right? I hope this is clear. Yep. Same thing will happen with vada also. Everybody has written vada also? Okay. This is your vada. Okay. This is your brown part, which is that vada, right? You try to eat vada and you find that horrible it is. It is soggy, it is soft, it's full of oil. It's not crispy at all. It's not even hot. You get angry, you throw the vada. You throw the vada. You throw the vada in air, it starts rotating, it spins and it goes like that. Maybe this point goes like this. Maybe this point goes like this. Maybe some other point over here will go like this. But there is a point somewhere here again. It's not on the vada, it is in the air, in that gap, in that hole. Okay? But that point can be associated with the vada with respect to the other points, right? And you will see this point will go in a parabolic path like this. Is that clear, my dear warriors? Is that clear, my dear warriors? Yes, so that is where basically the center of mass is. That is basically where the center of mass is. Awesome. So, to briefly describe center of mass is the place where entire mass of the body can be assumed to be concentrated, right? And behaves just like a particle, right? Now remember one more thing. The center of mass can lie on or in or outside the body. It can lie anywhere. For example, imagine if I take a disc. Okay, imagine this is like a disc. This is full of some mass. It's a complete disc. Where is the center of mass going to be? The center of mass is going to be here. This is exactly where the center of mass is. This is on the disc. This is a part of the body. But if you take a ring, then the center of mass is over here. It's not on the ring. It is not inside the ring. It is outside the ring's body. Or even if you take, imagine a horseshoe shaped kind of a magnet. Okay, the center of mass could probably lie over here. It is not on the magnet, it is outside the body. So it could lie outside the body, on the body, inside the body, anywhere. Is this concept clear? Everybody with me? Awesome. Hello Crazy Khaleds, hello V. Nice to see all of you. Hello Santhini. Very good Vishwa. Very good Himal. Yeah, SHM will do it later on, bacha. First let's complete this, then rotation will go to SHM also. Definitely. One more thing, one more misconcept. Center of mass is not the same as center of gravity. Completely different things. Center of mass is where the mass is concentrated. Where the mass is basically concentrated. But when you talk about center of gravity, it is where the weight is concentrated. What is the difference between weight and mass? Everybody knows. Mass is scalar, weight is vector, mass is in kgs, weight is in Newton, mass is the amount of matter, weight is the gravitational force acting on a body. Two different things, right? So now tell me one thing. Imagine we take a Pandu, okay? This Pandu is on earth, he's standing on earth, okay? There is a tree over here, whatever, okay? He's standing on earth. Then that same Pandu becomes an astronaut and he's floating in space. He's floating in space. This is in space. Tell me, on earth there is gravity, right? On earth there is definitely gravity is there. There is gravity. But in space, it is basically gravity free. It is a gravity free region. There is no gravity. You're floating in space somewhere really, really far away from our solar system. Hardly any pull is there. Agree or disagree? Okay. Now, in space, do you have mass? Yes. Do you have weight? Do you have weight? Tell me in the chat box. You have mass, but do you have weight? What is your weight in space? What is your weight in space? You have zero, right? You have zero weight, right? So do you have center of gravity? No, there is no weight. There is no center of gravity because COG, center of gravity, is where the weight is concentrated. Where the weight is concentrated. If there is no weight, what is the point of COG? So over here, I can say COG, center of gravity, is not even there. But mass, matter, obviously Pandu is made of some mass. Center of mass is definitely there. No gravity, no center of gravity. Awesome. But in this case, don't you see, Pandu has mass, Pandu's weight is also there. So it has both center of gravity as well as center of mass. So in this case, I can say center of mass is also there and center of gravity is also there. Both the things are there. Keep in mind, center of gravity is not a part of your NEET syllabus. You just need to know that they are not the same thing. They are two different things. Is the center of mass going to be the same as the center of gravity? For most of the objects, center of mass and center of gravity will roughly be equal to each other, will roughly be close to each other. But for very big bodies, you will see the difference will be significant. Okay, the difference will be significant. Like for example, imagine you take a very, very tall object on earth, very, very tall mountain on earth, rock on earth. Then at the top there is very little gravity. So gravitational force is less. As you go down, the gravitational force will increase, right? Because G will increase. So G is more here. G is less as you go on the top. So where is the gravitational force concentrated? Well, it will be somewhere over here. Maybe this is where the center of gravity is. But matter wise, these particles, this body, this rock, this mountain, whatever this object is, building, tree, anything, this is made up of matter. The mass might be concentrated over here. Maybe this is where the center of mass is. So they are two different things. They are two different things. Got it, everyone? So generally, for most objects, they are same. But for very tall, huge objects, you will see the difference becomes very, very prominent because gravitational force might change significantly with height after some time. Right. Very good. Awesome. Awesome. Great. So with this, let's actually see how to find the center of mass of different particles. So till this point, what have we learned? Center of mass can lie anywhere inside, outside the body, right? It can not be the same as center of gravity. It is two different concepts. COG is not a part of NEET syllabus. Keep this also in mind, right? Just 1 second, guys. Okay. Now, let's see the formula for center of mass. To find the formula for the center of mass. Okay. To find center of mass of particles. To find the center of mass of particles. Let's find it. to find the center of mass of particles. Let's try this. Okay, now the thing is, usually the kind of problems that you get for finding the center of mass of particles, you'll be given one particle is here, one particle is here, one particle is here. Find where the center of mass is. It's purely formula based, and I'll tell you what that formula is. Okay, so here it goes. Imagine there is one particle of mass m1 here, there is another particle of mass m2 over here, maybe there is another particle of mass m3 over here, so on and so forth. Maybe there is a particle of mass mn over here. Each particle could be anywhere, some x coordinate, some y coordinate, some z coordinate, anything, guys. Something is there. Okay, something or the other is there. 1 second. Yeah, something or the other is there. They have some x coordinate, some y coordinate, etc. This is x coordinate, this is y coordinate, maybe this is x3, maybe this is y3, maybe this is x2, maybe this is y2, maybe this is xn, maybe this is yn, and so on and so forth. These are basically the coordinates of the particle. These are basically the coordinates of the particle. Right. Now, where is the center of mass concentrated? Let's say it is over here. This is where the center of mass is. Let's say the coordinate is xcm, ycm. xcm, ycm. These are the coordinates of the center of mass, where if you combine all the particles together, this is where the mass is concentrated. The formula looks something like this. The x coordinate of the center of mass is given by m1 mass 1 into, for x coordinate use x coordinates only, x1 plus m2 x2, like that go till the nth term, divide it with the total mass, that means m1 plus m2 plus dot 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 till the nth mass. Same way for the y coordinate of the center of mass, take the first mass, take the first y coordinate. So it will be nothing but m1 y1 plus m2 y2 plus dot 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 divided by m1 plus m2 plus dot 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 till the nth mass. So this is the formula for finding each x, y, or even the z coordinate. I have not put z over here, but if z was there, the same formula will hold. So if it is in 3 dimension, no issues. If it is in 3 dimensions, then the z coordinate of the center of mass will also have the same formula. It will be m1, use z coordinates only, z1 plus m2 z2 till the nth mass, the whole thing divided by the total mass, m1 plus m2 plus dot 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 till the nth mass. So it will work for 2D, 3D, or even 1D. Let's take examples and then maybe understand how to use this formula, because many times many students make some silly mistakes over here. These are very direct questions. So let's try to understand how to use this formula. Okay, formula, you have written it down. Formula is by-hearted. Formula is there in your head. Try to remember this formula. Take maybe 20-30 seconds. Recite this formula again and again. Let it be stored in your head, because we are going to use this formula now, okay, to find the center of mass. So let's take a simple example for now. Let's say there is one mass of 20 kg over here, and let's say there is another mass of, let's say, 30 kg over here, okay, and let's say they are on the x-axis. Let's say they are on the x-axis. Okay, let's say this is the origin. Let's say this is basically x is equal to, I don't know, maybe 3 meters. Maybe this is x is equal to 13 meters. Just taken some random coordinates. I want to find where is the center of mass. Thank you for that comment. Sir, you are only the mass, sir. Okay, thank you. Okay, so let's see how to find the center of mass. Center of mass will lie somewhere in between. Will it be closer to 20 or closer to 30? I feel it will be closer to 30, because this is more heavy, more mass. So I think center of mass will be slightly closer over here. Maybe this is where the center of mass is. Cool. So what you will do is basically understand, use the formula xcom, x coordinate will be m1 x1 plus m2 x2 whole thing divided by m1 plus m2. Okay, what is mass 1? First mass is 20 kg. What is x coordinate? It is basically 3 plus. What is mass 2? Well, that is 30 kg. What is x coordinate? Well, that is 13. The whole thing divided by the total mass. So that is 20 plus 30. Come on, my dear warriors, do the math and tell me what is it that you are getting. 23 is 16, 30 into 13, that's 390, and you have 60 over here. That's going to make it 450. Just check this out, right? 0, 0 cancels. So I think you're going to get the answer as 9 meters. How many of you got the answer as 9 meters? Very good. Nandini has got it. I think Karthik made a small silly mistake over there. Very good, Mishra. Very good, Saithi. Very good, Senthil. Very good, Subhashini. Very good, Austin, Trisha, Sangeeta, Nick. Awesome. That's how you find it. This is for 1D. Let us now take a problem of 2D. No issues. It will be still simple only. Okay. See, guys. Imagine one particle is here. Let's say I'd call it as 1 kg. Another particle is, let's say, over here. Let's say it is 2 kg. Let's say one particle is here. Let's say it is 3 kg. Let's say one more particle is here. And let's say it is 5 kg. And these are on the, 4 kg. All right. So let's say this is, these are on the vertices of a quadrilateral, which is basically having sides equal. That means it is a square. A. And I tell you, listen, this is my x-axis and this is my y-axis. Naturally, this point over here will become the origin. Okay, so that point over there will naturally become the origin. Find the coordinates of the center of mass. Let's try to find the answer, guys. Let's see how many of you are really quick about this. Let's start with the x coordinate of the center of mass. What will I have? 4 masses are there, so 4 terms will be there. So plus. So 4 terms will come over here. And here I will have again all the 4 masses. So let's start with this mass. Mass is 1 kg. Okay, 1 kg. Into, what is the x coordinate? It is on the origin. So 0. So 1 into 0. Second mass, 2 kg. Okay, 2 into x coordinate. Guys, it's on the y-axis. What is the x coordinate? On x-axis, nothing, right? The x component, x coordinate will be just 0. So it will be just 0. Go to 3 kg. Okay, so m3 into, what is the x coordinate? It is just a, right? So it is just a. Perfect. Next, 4 kg mass. So mass is 4 into the x coordinate. What is the x coordinate? It is just a, right? So just put a. That's it. Upon total mass. What is the total mass? 1 kg plus 2 kg plus 3 kg plus 4 kg. Do the math. This is 0, this is 0. 3a plus 4a. 7a. Okay. Divided by 1 plus 2, 3. 3 plus 3, 6. 6 plus 4, 10. So 7a by 10 is the answer for the x coordinate of the center of mass. 7a by 10. Very good. I think some of you have written it. Awesome. Similarly, my dear warriors, what about the y coordinate of the center of mass? It will be nothing but same logic. Mass 1, 1. Y1, y coordinate is 0. So 0 plus mass 2, 2 kg. Y coordinate is itself a plus mass number 3, the y coordinate is a. Mass of 3 kg, y coordinate is a plus 4 kg mass has 0 coordinate in the y direction. So into 0. Whole thing divided by total mass 1 plus 2 plus 3 plus 4. So how much will it be? 2a plus 3a is 5a. So this will be 5a. This will be nothing but 10. That means it will be just a by 2. So 7a by 10 comma a by 2 is the final answer. Very good. Awesome. So this is how you find center of mass of different particles, guys. Okay, now whether you get small system, big system, many particles, it's the same procedure. But sometimes there is a trick which you can use, and without using this formula, especially for 2 particles, you can find the answer directly. Do you want to know the trick? Do you want to save maybe 30 to 50 seconds in solving the problem? 30 to 50 seconds. You might be like, sir, it's nothing. But let's just multiply it with 40 questions, 45 questions. Oh, that's close to, at least half an hour. You can save half an hour by knowing some tricks in each and every question, by thinking properly in the right way. You can save a lot of time. So that's how, the effect of, multiplication works for all the things. If you use tricks, you might save a lot of time. Are you ready to know the trick? Well, here it is. The trick is very simple. It's called as the ratio trick, okay? Ratio trick to find center of mass. What is the ratio trick say? It just says, okay, the center of mass divides the distance between the two masses in inverse ratio of masses. In inverse ratio of the masses. Statement wise, you might not really appreciate it, but when I show it to you, you'll be like, oh my god, is this what the trick is? Observe. Imagine this is mass m and imagine this is mass 2m. Okay. The line joining them is basically this. Let's say I call it r. R is the distance between them. Guys, can you quickly think and tell me what is the ratio of masses? What do you think is the ratio of the masses? This is m, this is 2m. This is 1, this is 2. 1 is to 2. Is that right? This is 1 is to 2. Now what you do is, the distance between the center of mass and any mass will be in the inverse ratio. Meaning, if by chance the center of mass is over here, this distance upon this distance will be inverse to the masses. Meaning, if this mass is more, this distance will be small because center of mass will be closer to the heavier mass. If this mass is small, this distance will be large because center of mass will not be close to the lighter mass, it will be closer to the heavier mass. So more mass, less distance. Less mass, more distance. That's why it divides the distance between the two masses inversely to the masses. This distance is proportional to this is proportional to this, or it is inversely proportional to the masses over there. So basically the distance ratio will be 2:1. Like, okay sir, still what is the trick sir? I feel it is still difficult to understand. No. See, writing 1:2 then writing 2:1 is a piece of cake. If you know this is m to m, okay, 1:2, inverse will be 2:1. What you do now, add the numbers 2 and 1. Add the numbers 2 and 1. What will you get? 3, right? What will you get? 3, right? Just divide r into 3 parts. Just divide r into 3 parts. R by 3, R by 3, R by 3. Now 2:1 means take 2 parts of this and take 1 part of this. 2:1. So basically this distance will be r by 3 and this distance will be r by 3 plus r by 3. That means 2r by 3. That's it. That is the answer. That is the answer. Let's apply to more problems so that you understand the trick properly. Just take the example of this is 2m and let's say this is 3m. Example, this is r. What is the ratio of the masses? Quickly, what is the ratio of the masses? Can you see it very easily? 2 and 3. So 2:3. So guys, what is the ratio of the distance? What is the ratio of the distance? 3:2. Correct? What will you do? Add these numbers. 3 and 2, if you add, what will you get? 5, right? You will get 5, right? 3 plus 2 is 5. So divide r into 5 parts. R by 5, 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 like that. Take 3 parts over here, take 2 parts over here. That's it, your job is done. So guys, if this is the center of mass, this distance will be this one. So 3 times r by 5. And this distance will be, there are 2 r by 5s over here. So 2 r by 5. Is that making it look very simple? Is that making it look very simple? Understood? Clear? Let me just go back a little bit and look at this example. Could we have solved it by other method? Answer is definitely a yes. Observe. Do you see the masses? What is the ratio of the masses? What is the ratio of the masses? 20 kg, 30 kg. That means 2:3. That means the ratio of the distance Won't it be 3:2? The ratio of the distance will be 3:2. Okay. What is the distance between 20 kg and 30 kg mass? What is this distance, guys? What is this distance? Ratio will divide it inversely to the masses. So what is this distance from 20 kg to 30 kg? This is at 3, this is at 13. Isn't this 10 meters? Isn't this 10 meters? So now just keep that aside. 3 plus 2, what is it? 5, right? So divide 10 into 5 parts. Divide 10 into 5 parts. So each part will be 2 meters, 2 meters, 2 meters, 2 meters, 2 meters. So this one and this one. 3 over here, 2 over there. So this is basically 6 meters. This is basically 4 meters. So hence the center of mass from here will be at 6 meters. Hence the center of mass from this point will be at 6 meters. But already this point is at 3 coordinate. So center of mass will be at 3 plus 6, which is 9, which is exactly what we got. But this method I feel was really quick, was really time saving. Good evening, Kashyap. I hope this is very, very clear. Thank you, Kalis. Is that clear, my dear warriors? Is that understood? Absolutely. Very good. Chalo. Let's do some questions now. Let's do some questions. Okay. The position of the center of mass of a particle does not depend on mass, symmetry, nature, relative distance between the particles. Which one do you think is not going to be deciding the position of the center of mass? Which of the following will not be deciding the position of the center of mass? Come on, my dear students. Think about it. Think about it. Yep. Is it option A or C? Students are confused between option A and C. Pakka, C for Captain Shreyas. Sure. Wow. Very good. Mass of the particles? Yes. Symmetry of the body? Yes. Relative distance between the particles? Definitely. See guys, if I have heavy mass over here suddenly, or this mass is light, again mass is very, very heavy. Obviously the center of mass will be somewhere over here, closer to the heavy particles. So definitely it depends on the mass. Symmetry of the body? Yes, definitely. Like I know 100%, if I take a cone like object, it will lie on the symmetrical axis somewhere over here. I know if I take a square object, I know the center of mass will be somewhere over here. So definitely it depends on the symmetry of the body. Relative distance? Yes, definitely. Imagine there are two particles over here. Okay. So now what you do, you keep this particle here, but this heavy particle, you move it away. You move it away. The relative distance has changed. So now if the center of mass was here, now the center of mass will also shift. The center of mass will also shift its position. So definitely it depends on the relative distance. The nature of the particles, what is the nature of the particles? Nothing. It does not depend on the nature of the particles. It's a particle, mass matters, coordinates matter, nothing else. Let's do the next question. This is also PYQ NEET 2020. Two objects of mass 10 kg and 20 kg are connected to two ends of a rigid rod of 10 meters length with a negligible mass. Can you guess the distance of the center of mass of the system from the lighter mass, which is 10 kg? Guys, I feel you can use my trick and give the answer within, I think, 5 to 10 seconds. Okay. Kashyap, this is a fresh new chapter, bacha. There is nothing to revise over here. Okay. This is a fresh new chapter. Yes. Come on. What do you think, guys? The answer is option B, is it? Pakka? 20 by 3. Use my trick. Use my trick and you will get the answer. Is it Pakka B or something else? Sure? Lock? Wow. You would have cracked the exam in NEET 2022, yeah. Very good, very good. Use my trick. What is the ratio of the mass? It is basically 1:2. So what is the ratio of the distance? It is 2:1. 2 plus 1 is basically 3. So divide 10 into 3 parts. So 10 by 3, 10 by 3, 10 by 3. Take 2 parts out of it and 1 part separate. So from here it will be 20 by 3 and here it will be 10 by 3. So from here till here is 20 by 3. Directly you can see from here. Correct? That's it. Use my trick. It becomes like, you know, a piece of cake. Let's go to the next one. This was asked in NEET 2020 exam. Let's see how many of you can crack it. 5 kg and 10 kg attached to two ends of a rod, length 1 meter, negligible mass. Center of mass of the system from the 5 kg particle. Can you believe this? Same type of question has been repeated twice. That means this is a very, very important kind of problem. You can mark it. This kind of questions will definitely come. Center of mass. Yes, Jyoti, your chat is visible, bacha. Come on. So guys, what is the answer? What is the answer? Okay. Somebody saying Captain Shreyas, C option. Somebody saying 67 centimeters. Okay. Very nice. A for aim, C for captain, B for bananas, D for doctor. Is the answer A for aims? Definitely it is. So guys, again similar thing. This is 5 kg and you have 10 kg over here and the distance is basically 1 meter, or you can call it also as 100 centimeters. So to find the center of mass, just check the mass ratio. The mass ratio 5:10, that means again 1:2. So the distance ratio 2:1. Add 2 and 1, it will give you 3. Divide 100 into 3 parts. 100 by 3, 100 by 3, 100 by 3. Take 2 parts over here and leave 1 part over here. So this is basically 200 by 3, which is 66.66 centimeters, which is close to 67 centimeters. Exactly. That is the answer. Simple, right? Loved my trick? So like the video also. If you loved my trick and if you realize that this can be a time saver in the exam, make sure you smash the like button right now. Do not forget, and do not forget to subscribe as well. Wow, we have a question of 3D. Something very interesting. JIPML 2017. Two masses, 6 kg and 2 kg units, or whatever, you can keep it. Okay, position vector 6i minus 7j. So that means coordinates are given. 2i plus 5j minus 8k respectively. The coordinates of the center of mass is center of mass coordinates. Guys, x1 is given, x2 is given, y1 is given, y2 is given, z1 is given, z2 is also given. Find xcm, ycm, zcm. Nothing more, nothing less. Direct application of formula. So x center of mass will be m1. What is m1? 6 kg. So this is your m1. This is your m2. These are your coordinates. These are your coordinates of each mass. So m1 is basically 6. x1 is basically also 6 plus m2 is 2. x2 is basically 2. Interesting. Whole thing divided by total mass. So 6 plus 2. 6 6 are 36. 2 2s are 4. 36 plus 4, 40. Divided by 8, which is basically 5. So 500% is that. So A option eliminated. A option eliminated. Similarly, find the y coordinate and also the z coordinate. Y center of mass will be m1 6, y1 minus 7 plus m2 into y2, which is just 5. Whole thing divided by 6 plus 2. Okay, this is divided by 8. 7 6 are 42, 2 5 are 10. So minus 42 plus 10, that's minus 32. So minus 32 by 8, that's going to be minus 4. So minus 4 is there in C option also and D option also. So only Z coordinate is remaining. Come on guys, find the Z coordinate also. Z center of mass, M1, 6. Z1, nothing. No Z coordinate only. Plus M2, 2. Z coordinate is minus 8. Whole thing divided by 6 plus 2. Okay. So divided by 8 again. 6 into 0, 0. 2 into 8, 16, but with a minus sign. So minus 16. So that means minus 2. Right. So I can see only one answer is matching. That is option C, Captain Shreyas. Perfecto. Very good, Subhashini. Very good, Josephine. Very good, Karthik. Yes, you guys got the correct answer, and you would have cleared JIPMER in 2017. But I'm pretty sure solving these problems is giving you the confidence for NEET 2024 as well. Moving on to the next question coming up on your screen. Which of the following statements are correct? Which of the following statements are correct? Center of mass of a body always coincides with the center of gravity. I told you, center of gravity is not there in the syllabus, but they can probably indirectly give a theoretical question, not calculative question, because calculation part is not there in the NEET syllabus, in a very different way. See, they have asked in NEET 2017. So it is more of general knowledge. It's more about, how much you have read the introduction part of the chapter. Because somewhere in many textbooks, it will be given center of mass, not to be confused with center of gravity and all of that. So you can see a question on that. Which of the following is correct, guys? Oh, it's multiple correct. Maybe two options are correct. Read the questions carefully. A couple on a body produces both translational and rotational motion. So it's also combined with rotational motion. So first clear your concepts of center of mass, then I think you can narrow down on at least two options. Is it option A, B, C or D? Yep. Come on. Kishore, mechanics will be covered, completed by the next 1-2 weeks. That's it maximum, because rotation is there, momentum collision is there, and SHM is there, right? So we'll try to finish it off this next 2-3 weeks max. Okay, so guys, the correct answer for this is, oops, I think the option marked over here was wrong. It should be probably something else. Let's see. The center of mass of a body always coincides with the center of the gravity of the body. This is wrong, right? This is wrong, right? Not necessary. Center of mass of a body is the point where the total gravitational torque of the body on the body is 0. Well, I think this is also wrong. It's not about the torque, it's where the mass is concentrated if you are talking about center of mass, right? So A and B both are wrong. So wherever B and A is there, those options can't be there. A couple on a body produces both translational and rotational motion in a body. Oh, I think there is something wrong in this, because even C is wrong, because I think the options were something else maybe. See, a couple on a body produces both translation and rotational motion of a body. That is wrong. Couple means two forces which are equal and opposite. Two forces which are equal and opposite. So what happens? Net force becomes 0, but these two forces produce a torque. So the torque is not 0. So rotation is there. Translation is not there. So they produce both translation and rotation. That is wrong. Mechanical advantage greater than 1 means a small effort can be used to lift a larger load. So it is option D. Yes, only D is correct. Yes, Kumar. That is right. Perfect. Yeah. So D option is correct. So center of mass always coincides with the center of gravity. That is wrong. Okay, it could be different. It could coincide. It depends from situation to situation. Like I gave you the example of Pandu in space. There was no center of gravity. How will it coincide? Mass was there, gravity was not there. So there are two different things. So do not confuse between the two. Yes. All right. Why B is not correct? See, center of mass of a body is the point where the definition only is wrong. The definition only is wrong. Center of mass is the point where the total gravitational torque is 0. No, that is not the definition of center of mass. It's where the net mass or the total mass can be assumed to be concentrated so that it behaves like a point mass. It behaves like a particle, right? Whatever a particle would do, the same thing that point is also doing on that body. So that was the definition. So it's a wrong thing by definition only. It's something else only it is given, some gravitational torque. No. What does gravity do with center of mass? Nothing. In the definition of center of mass, gravity has no role only to play. If gravity is more or less or torque is more, nothing will happen. It's mass. Mass is matter. If gravity is more, how will the mass change? Weight will change. COG, center of gravity will change. Mass will not change. Understood the difference? Understood the difference? Very good. Very good. Keep this in mind. Awesome. Many people get confused over here, but I'm so glad you guys asked the doubt also and you cleared it out. All right. So now it's time to go to more, other variety of questions. So before that, let me tell you the theory part of it. See, the formula which I gave you sometime back right over here, the formula which I gave you sometime back over here, right? This one. Yeah, this one. This is okay when you have particles. There are many particles and you want to find where the center of mass is located. But not every time you can locate the particles, that's the problem. So sometimes you will see that the bodies are continuous. Sometimes you will see that the bodies are continuous. Take the example of this. What is the example of continuous bodies? Continuous bodies. Best example, sphere, shell, right? Cone, cube, right? Pyramid, right? Cylinder. These are the standard geometries. There are so many more examples. A tree, a person, a table, right? A building. All these are examples of continuous bodies. Can you count 100 particles? Definitely not. If I ask you, how many particles are you made of? Your whole life will go away, but still you will not finish. One useless task and you will feel completely worthless. So guys, where things are not countable, you can see it's a continuous distribution. All right, it's a continuous body. So the formula for them will slightly change. These kind of systems will be studied under continuous bodies. Is that clear? Yep. Awesome. Now, what is the formula for that? So here is the formula. Imagine this is some random continuous body. Okay. So to find the center of mass, take small masses. Let's say you take dm mass. It's basically also called as an elemental mass. It's so small. I mean, what can I say? It is not zero, but it is very small. That small mass will have some x coordinate, correct? It will also have some y coordinate, so on and so forth, right? It will have some x coordinate. It will also have some y coordinate and all. So use the same formula, but for many particles. Use the same formula of normal center of mass, but for many particles, so that sum for a very large set of numbers where each particle's mass contribution is very small, that mathematically will just become integration. That's all. So when I say, okay, the center of mass is over here, then the x coordinate of the center of mass actually should have been the sum of x into dm. Then I go to next dm, that x into that dm, next dm, that x into that dm, x dm. How many times? So many times. Sum of x dm. Many terms will be there. Almost infinite terms will be there. And basically you will have again sum of all those dms on that body, on that particular body. So that is basically called integration. So it will be integral x dm, sum to that is integration upon dm plus dm, that will be integration of dm. So that is your x dm formula. Same way not dm, center of mass formula. I got carried away. So xcm formula. Similarly, ycom formula will be integration y dm upon integral dm. Similarly, z coordinate of the center of mass will be integral z dm upon integral dm. That is the formula. That is the formula application part. Okay. So we'll see how to use this formula for 1 or 2 examples, and then I'll use some standard geometries which you will have to remember. Yes. Work power energy, there is no collision because obviously collision is a separate lecture only, separate chapter only. Yeah. So Shreyas, you can attend the classes here also, no issues. Okay, the classes are going on YouTube, and if you are already a part of JEE, Energized batch, there I have already covered those topics in the actual platform batch, right? Okay, now for standard objects, it lies on the point or the line of symmetry. So for uniform symmetrical bodies, the center of mass lies on the point or the plane of symmetry, point or that line or that plane of symmetry. What do I mean by this? Say for example, I take a sphere. Okay, I take a sphere. Where will the center of mass be? It will be over here, because this is the point which is the point of symmetry. Everything is equidistant from that point. Everything looks the same, whether you go up, down, left, right, front, back, it's the same. So that's the point of symmetry. Same way, if I take, let's say for example, a cuboid, okay, let's say like this. If I take a cuboid, let's say, something like this, then we all know the point of symmetry will be somewhere at the center of the body, where all the diagonals intersect. From here to here, if you draw a line, from here to here you draw a line, from here to here you draw a line, from here to here you draw a line, you will see they will intersect here. It's somewhere between the top and the bottom face, somewhere exactly in between left and right, front and back face. So that is where the center of mass is, right? Same way, if I take a cylinder, okay, like this, if I take a cylinder like this, right, you will see that the center of mass will lie exactly on the axis, exactly at height by 2, exactly over there. So it's always going to lie on the point or that line of symmetry, right? But sometimes you might not be able to get that precise point. Let's say for example, a cone. Something like this. Awesome. So over here, can you say the center of mass will be exactly at height by 2? No, right? It won't be at height by 2, because I can see more masses there below than over here. But I know 100% it will lie somewhere over here. 100%. This is your line of symmetry. 100% it will lie over here, but it will be more towards the downside, maybe, somewhere over here. It can't be on the top because less mass is there on the top. Same way, my dear warriors, if I give you a hemisphere, something like this. Yep. Look at this, guys. Over here, 100% it will lie on this line, because this is your line of symmetry. Everybody agrees with this? So guys, do you also agree that it can't lie on the top because the base is wider, the top is narrower? 100% the center of mass will be somewhere below only. It can't lie on the top. That's how it works. So remember, it will always lie on the line of symmetry, or at least on the point of symmetry of that uniform body. Now you might be wondering or questioning, sir, where exactly is that point? Well, there is a formula which I just gave you. Using these formulas, you can find where the center of mass is. But let's take a simple problem first. This, if it comes in the NEET exam, very few people will solve it. Probably less than 10,000 or 20,000 students. So you can think as if this is like the 0.1 percentile of students will solve it. The question is, do you want to be one of them? If you want to be one of them, then concentrate on this problem. Okay, so you can be in the top 10, 20,000 in the entire country in the NEET examination. Okay, so this can come in section B, or this will be one of the good problems in the NEET exam. Like, say for example, Imagine they tell you there is a rod like this. This is a rod, okay? And let's say this is your x-axis, this is your origin, this is obviously your y-axis, okay? This rod is made of non-uniform density, such that the density at any place is rho naught into x coordinate. Rho naught into x coordinate. The question is, find the location of the center of mass. Understand what this means. If x is less or low, that means on the left side, it is less dense because density is less. As the x coordinate increases, the density also rises. So it becomes more dense. Maybe there are few particles only over here. But as you start going towards the right side, you start seeing more and more number of particles. You can think of it like that. So this is very dense. This is less dense. Are you able to see that thin gradient? Are you able to see that faint gradient? Less dense, more dense, more dense, more dense, extremely dense. So the density of the rod is only different. So guys, think about it. Will the center of mass be exactly at the center? Because if the rod was a uniform rod, just imagine if this was a uniform rod, 100% the center of mass would lie at length by 2. It would have, been placed exactly at the center. But I feel in this case, I don't think the center of mass will be at the center. It will be slightly more towards your right side. It will be slightly more towards your right side. How many of you are able to visualize this? How many of you are able to visualize this, guys? Yep. Are you able to see that? Very nice. Very nice. Very nice. So where exactly it is what we have to find. So I think we should use our integration formula because I can see it's a variable problem. I can see it's a continuous body problem. So most likely I will shift to integration. So observe this carefully. So just imagine I take a small mass over here. Imagine I take a small mass over here. Let's say the mass is called dm. It is at a distance of x and the width of that is dx. The width of that is dx. Using our XCOM formula, which is integral x dm upon integral dm, I cannot integrate this. Don't say, sir, that is x square by 2, sir. No. How is it x square by 2? It is not integrated with dx. So I need to convert dm into dx some way or the other. How to do that? Observe that element. If you take that element on that rod, if you take that element of that particular rod, it will look something like this. Okay, this is a very zoomed in version. You zoom onto it. This is how it looks like, right? This is how it looks like. Okay, this will have some area of cross section. This will have a width dx. Isn't it like a small cylinder? Very nice. Now, if I ask you the density of the cylinder, what will you say? It is the mass of the cylinder, which will be dm, upon the volume of the cylinder. What will be the volume? It will be the area into the height of the cylinder. But wait a minute. Just over here, density is given as a function of x. So can I write it as rho naught into x is equal to dm by a into dx? Just rearrange the terms. You will get dm is equal to rho naught a x dx. Whoa, this is amazing. I got the value of dm. It is rho naught into a into x into dx. So why not substitute dm over here? So why not basically substitute dm over here? X is as it is. This integral is also as it is. Wherever I see dm, I'll just substitute it with this. So it will be rho naught a into x dx. Same thing over here also, rho naught into A into x dx. See now what happens in the next step. I think rho naught A is a constant, so it will just come outside. Same thing over here, rho naught A will also come outside. On the top, you will have x into x is x square integration. At the bottom, you just have x's integration with respect to dx. Now, what will be the limits of the integration? Obviously, it can't be limitless. It has to be with some limits. Hello, Madhu. Hello, Buddha. Okay, nice to see you back to Buddha. So, guys, what will be the limits? See, where will the first element be? It will be here. Then it will slowly go here, here, here. You have to consider all the elements still here. So, from 0 to L. From 0 to L. So, if L is the length of the rod, so I think the limits also should be from 0 to L. From 0 to L, right? Not just that, you also can see rho naught A cancels numerator and denominator. So what is left over here? So x square's integration will be x cube by 3. X cube by 3, limits are 0 and L. And at the bottom, x's integration will be x square by 2, 0 and L. Substitute L, then substitute 0. You will get L cube by 3 minus 0. Alright, L cube by 3 minus 0. And whole thing divided by here, L square by 2 minus 0. L cube by 3 minus 0 is L cube by 3. Same thing. Denominator will be just L square by 2. So take 2 on the top. I think 3 will remain below. L cube will remain on the top. L square will remain below. So L square cancels. I think it will become 2L by 3. That is the answer, guys. 2L by 3. Very good, Jasper. Good evening, everyone. Definitely, Sangeeta. So all the important chapters will be done. Yeah, much before December only. Okay, we'll be starting, revision mock tests and PYQ series by December for sure. Cool. So I hope this is very, very clear. Everybody has understood these pointers. Awesome. So what are some, bodies whose center of mass you should remember? You don't have to know the derivations. Derivations not important. Ignore. So what are those things? So if you have a hollow hemisphere, then you have basically solid hemisphere, hollow hemisphere, then a solid hemisphere. So hollow means it will be like this. Solid also will look like this only, just that it is made of solid part. That's all. That's the only difference. So when you talk about hollow hemisphere, the center of mass is at basically r by 2 from the base. The center of mass is at r by 2 from the base. But when you talk about solid cylinder, then the center of mass is at a distance of 3r by 8. Okay, 3r by 8 distance. Keep this in mind. Okay, this is for hollow hemisphere. This is for solid. Hollow means, it's like a cup, like a bowl. Okay, inside is empty, scooped out. This is completely solid. It's like taking a solid ball and cutting it into two halves, like taking the earth and cutting it into two hemispheres. Same way, you also have hollow cone, as well as you have solid cone also. So hollow cone, this is a solid cone. Everybody likes cone ice creams, right? Waffle cone with chocolate, Belgium chocolate, mango flavor ice cream, butterscotch, this, that. You would have taken or eaten ice creams. So if the cone is empty, nothing is there. That's hollow cone. You fill it with ice cream, right? That's solid cone. Or your birthday cap, hollow cone. You fill it with something. Somebody fills it with mud to play a prank. That will be a solid cone. Great. So, guys, over here, in this case, for hollow cone, from the base, the distance is h by 3. This is where the center of mass will be. And for solid cone, remember, it is h by 4. That's where the center of mass is. Keep these pointers in mind. Okay? All these things you should know. Next important thing which you should know is for a triangular sheet, it's a triangular lamina, or basically a sheet. Doesn't matter whether it is isosceles, scalene, equilateral, doesn't matter. It is always going to be the center of mass. The center of mass is always at the centroid of the triangle. Centroid is basically the point of intersection of what? The point of intersection of what, guys? Medians. Of medians. The point of intersection of basically medians. Median is the point, line which joins the vertex and the midpoint of the opposite side. So the vertex and the midpoint of the opposite side. The vertex and the midpoint of the opposite side. So this is where the centroid is. Is that okay? You should know this as well. Okay, awesome. Last geometry which you should know. Everybody must have eaten pizza. How many of you love pizza? How many of you order pizza regularly? Or how many of you are like, no sir, pizza too much cheese. No sir, parents scold me. No sir, not allowed. Thank you, Sangeeta. Double chocolate fans also over here, very good. So everybody loves pizza. And how many of you from the pizza slice like to eat the crust or that crust, that ending part? Okay, a lot. And there are many people who like to eat the entire pizza with the toppings and the cheese and the base, everything. So both kinds of people might be there over here. Both kinds of people might be there over here. So if you just like the end, somebody eats the center part, only the end part where there is no topping, the circumference part, that is like your arc. But somebody likes the entire pizza slice in itself, that is like your sector. It is completely full of some particles. Okay. Oh my God, some of you didn't eat pizza. No problem. When you go to medical college, you will eat pizza, burger, everything. Hopefully. Because you will not have time only, to study. So I'm like, something, let's order. Macha, see what is there. What is the new offer? Domino's. 1, 2, 3, 4, 5, 6 people. 6 people, 2 large pizzas. Done and dusted. Very good. Okay. So, over here, 100%, the center of mass must lie on the axis of symmetry. This is the axis of symmetry. Here also, it must definitely lie on the axis of symmetry. Assume that this angle is already given to you. This angle is given to be theta. Same thing over here. This angle is also given to be theta. Radius is r. Here also the radius is r. The center of mass will lie very close to the arc, somewhere over here. Okay. It will lie probably somewhere over here. This is where the center of mass will lie. This distance is what I am giving you. This distance is what I am giving you. That distance is given by r into sine of theta by 2. Theta by 2 is inside. Upon theta by 2 is also there, but in the denominator. This is a distance from the center to the point where the center of mass is. But for sector, which is completely solid, the center of mass is slightly closer to the center. It's slightly closer to the center. Same formula is there. You still have r into sine of theta by 2 by theta by 2. But there is one more number over here, and that is 2 by 3. So just multiply 2 by 3 for sector. Don't have to do anything over here. That's all. That's the difference. How to use these formulas? Observe. How to use these formulas? Observe. Example, they ask you to find the center of mass of a semicircular disk. Of a semicircular disk. This is a semicircular disk, for example. What will you do? You will use Captain Shreyas Sir's amazing formula for pizza. Amazing formula for pizza. Okay. A disk, is it like an arc or a sector? I think it is like a sector, but theta will be how much? 180 degree. A semicircle, what is it? 180 degree. Correct? Angle will be there. So think of it this way, guys. This whole angle will be 180 degree, or basically pi radians. Pi radians, or basically 180 degree, right? So we know for sure that the center of mass will lie somewhere over here. We have to find this distance. This is where the center of mass is. So what is this distance? By the formula, it is 2 by 3 because it's sector. 2 by 3 r sine something by 2, something by 2. What is that something? It is pi by 2 over here and also pi by 2 over here. Okay. What is sine of pi by 2? Sine of 90 degree, not 180, sine of 90 degree. It is 1. So it is 1 on the top and this pi is there over here. Shift this 2 on the top from below. So 2 2s are 4. So I think it will become 4r by 3 pi. 4r by 3 pi. Awesome. 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 Work per energy is done. Work per energy is done, bacha. What do you want? Second part. Everything was done last lecture. Okay. So my dear students, there is one place where you can do a mistake. Please, please, please remember one thing. Always substitute the angle in radian. If you don't, you'll get a wrong answer, because if you'll put 180 by 2, you will get 90 over here, 4r by 90 or whatever, 2r by 90 or into 3, something like that you will get, which is completely wrong. So be very careful. Theta has to be in radians. Has to be in radians, because you will get a wrong answer. Completely incorrect if you put theta in degrees, especially in the denominator part. Got it? This is the first and last part, because center of mass, half the chapter has been removed. Motion of center of mass, Newton's laws of motion for a system of particles has been removed. So that part is not even there. Similarly, my dear students, imagine a question like this comes. A quarter of an arc is there. This is your x-axis. This is your y-axis. And they tell you, listen, the radius is basically r. Question is, find the location of the center of mass. Find the location of the center of mass. All right. What are the coordinates? Etc. Something like that. So let's see how to do this question. Guys, concentrate on the class. Don't ask, sir, when are you going to do that? When are you going to do this? Obviously, I'll be doing it. Yeah, collisions I will do after this. And rotation will go after this. SHM will also start after this. So don't worry. Concentrate on the class. All right. Chalo saga. So my dear students, what do you think? How should we do this problem? This is like an arc. So for an arc, I know, again, if I draw the angle bisector, something like this, this is your line of symmetry. So center of mass will lie somewhere over here at some distance from the center. This is where your center of mass will be. Okay, so what is that distance going to be? Use the formula. R sine theta by 2 by theta by 2. Okay, so R sine of, what is theta in this case? Observe and tell me. What do you think theta is? I think it is 90 degree. Theta is 90 degree. Everyone with me on this? So shall I put over here, instead of theta, I'll put 90, which is pi by 2 divided by pi by 2 by 2. Okay, so what does it come out? That distance comes out as R sine pi by 4, which is 45 degree. Sine 45 is 1 by root 2 divided by, this will become pi by 4. So this will become 4r by pi root 2. That is the distance from the origin. But that's not all. We have to find the coordinates. So how to find the coordinates? Observe. If you drop a perpendicular here and here, aren't you saying this is basically your x coordinate? Is this not your y coordinate? In fact, this angle or that angle, both angles are 45 degrees. This line makes 45 degrees here, 45 degrees there. So both y coordinate as well as x coordinate, both are going to be d sine 45, or if you use cos 45 also will do, because sine 45 is equal to cos 45. We all know that. So d cos 45 or d sine 45, one and the same thing. So what are those coordinates? D value is 4r by pi root 2. Sine 45 or cos 45 is 1 by root 2. So this will become 4r by pi into 2. 2 and 4 cancels. So it will become 2r by pi. So basically the coordinates are 2r by pi, comma 2r by pi. So those are the coordinates. Done and dusted. Done and dusted. So in this problem, if you notice, this is an application of this formula, arc formula. I told you for pizza problems, there are only two cases. One, it is completely solid like a sector, or only the arc is present. If it's completely solid like a sector, you use that formula. I give you the example of a disc. All right. It could be a quarter of a disc, semicircle, any angle, use the general formula. Just need to know the angle in radians over here. For a quarter of an arc, I knew the total angle was 90 degree. So theta was put as 90, basically pi by 2. So pi by 2 by 2 is pi by 4. Pi by 4's sine is 1 by root 2. Sine 45 is 1 by root 2. That's what I put over there. But that was only this distance. I needed to find both the x and the y coordinates, coordinates of the center of mass. So this x is d cos 45, this y is d sine 45. So whether you use sine 45 or cos 45, it's one and the same thing. Both the coordinates are equal. Both the coordinates were equal. So I substituted sine 45, I substituted d and simplified to get the answer. Is that okay, Sangeeta? Right, everyone? Clear about this? Clear about this concept? Let me know in the chat box. If you are clear, then we'll go ahead. If you are clear, then we'll go ahead. Yes? Okay, great, great. Very rarely they might give you these kind of questions also, which I'll tell you, where 2 or 3 objects are combined together. But again, those will be easy problems only. Don't worry about it. Let's say, for example, a problem on composite bodies. Composite bodies. Best example, let's say some body is there over here and another body is joined to it. Question is, what is their total center of mass? If you know center of mass of this body, if you know center of mass of this body, you know center of mass of 1, center of mass of 2, then their combined center of mass might be somewhere, let's say over here. So the, let's say for example, the x coordinate of the center of mass will be mass of this body into x1, coordinate of the center of mass of the first body, plus mass of the second body into coordinate of the center of mass of the other body upon the total mass, m1 plus m2. That's all. So when 2 or more bodies are combined, treat each body like a point mass and use the center of mass formula, you get the answer. I'll show you an example. The same logic also holds true for bodies with cavity. For body with cavity also you can use this. For a body with, let's say, some cavity. Example, there is some body over here, there is some cavity. This is solid. There is some hole, there is some, missing part inside the body. You can think of this as if it's the same body, but completely full, minus that part which has been just taken out. Minus that part which has been taken out. So let's say this is first body, this is second body. Maybe the first body has a center of mass here, second body has a center of mass here. All right, this is center of mass of first body, this is center of mass of the second body. Then this complete body's center of mass could be here. So the x coordinate of the center of mass will be m1 x1, but instead of plus you put minus m2 x2 upon m1 minus m2. That's the only change. So whenever there is a cavity, something has been taken out, you put minus sign both numerator and denominator. When you add 2 bodies, then you put plus. That's the difference. Is this formula in your head? Then I'll show you the application. I'll show you 2 problems. Ready for it? Okay. Let's apply these formulas. Now, look at this. Imagine there is a square and there is a semicircle. Imagine there is a square and there is a semicircle. This is side length A, something like this. And This is my x-axis. This is your y-axis. Obviously, this point happens to be the origin. Question is find the coordinates of the center of mass. Find the coordinates of the center of mass. It's a sheet-like object. So it's a semicircular disc. Visualize it. Okay. If you try to visualize it, it will probably look something like this. Are you able to visualize it now in 3 dimension? Okay. Are you able to visualize that in something like 3 dimension? Okay. It's a thin disc, semicircle, and a thin square sheet like object. Right. Great. Question is, where is the center of mass going to be? Now, what you will do is, you will separate it out into 2 bodies. It's a composite body. Why? Because 2 bodies are joined together. First body is a semicircle, second body is a square. So 2 bodies are joined. So it's a composite type of problem. It's not a body with cavity. Okay. So if you look at body number 1, if you just look at body number 1, which is right over here. Okay. It will have some mass. It will have a position of the center of mass. So if this is the x coordinate, this was the y coordinate, something like this. What might be the mass? What might be the coordinates of the center of mass? Well, 100% center of mass will be somewhere over here only. This is center of mass of the first body. I think the x coordinate will be just 0. X coordinate will be just 0 because it is not on the x-axis, it is only on the y-axis. What will be the y coordinate? Oh, this is a disc. Oh, this is just a disc. So think about it, semicircular disc. So what will be the formula that you will use? Just the one which I gave over here. 2r by 3 sine theta by 2 by theta by 2. So just use that same formula. So 2 times r by 3 sine of total angle was 180. So pi radians by 2 by pi by 2. So I think you are going to get this as 4r by 3 pi, because 2 2s are 4, r is there, 3 is there, sine 90 is 1. Perfect. This much is done. This much sorted. Everyone with me? Now go for the square. The square is over here. Do not forget, the coordinate system is still like this. Okay, this is what your coordinate system is. 100% the center of mass is over here. If this is A, I think this will be just A by 2. So the x coordinate will be 0 because it is not there on the x-axis. But the y coordinate will be minus A by 2. How many of you realized it? Minus, because it is on the negative y-axis. It's not on the positive y, it's on the negative y-axis. Oh, but we had to give entire answer in terms of A only. We had to give the entire answer in terms of A. So is radius related to the side length? Yes. Can you see over here? The radius is actually half the side. Can you see over here? The radius is actually half the side of the square. Okay, so instead of r, if I put a by 2, won't it just become 2a by 3 pi then? Everyone with me on this? Everybody with me on this? Let me know, guys, in the chat box. Till this point, if everything is clear, then we'll go ahead. So what all we have done? We have divided into 2 parts, semicircle and square. Semicircle, center of mass will be here. X coordinate is not there. Y coordinate, I use the standard formula which I just gave you. Square, center of mass will be exactly at the center. It is on the negative y-axis, so that's why it is negative. X-wise, it has no coordinate. Okay. Now the last thing is remaining, and that is the mass. Now be careful with the mass. It's a sheet-like object. Won't the mass be proportional to the area? Think like this. If you have a sheet, okay, if you take a small area, less mass, large area, large mass. So won't the mass be proportional to the area? So can I also say mass per unit area will be the same? Usually the symbol used is sigma. Mass per unit area will be basically the same. If I take a small area, less mass, more area, more mass. Make sense? Similarly, if somebody would have taken a linear object line wise, this is a small rod, this is a large rod, this is a linear object, this is a linear object. Won't the mass be directly proportional to the length? So can I say mass per unit length? Mass per unit length is a constant. The symbol usually used for that is lambda. The symbol usually used for that is lambda. Lambda is basically kgs per meter. This many kgs per meter. More meters, more kgs. That's what it says. Same thing you can also apply for 3D objects. Big volume versus small volume. Imagine this is not a sheet or a line. This is a volume. This is volume, or basically imagine a three-dimensional object. Can I not say the mass will be directly proportional to the volume? So can I also say mass per unit volume will be constant? Usually symbol is rho. This will be constant again. So for linear objects, lambda. For sheet-like objects, sigma. For volumetric three-dimensional objects, rho. I think these are also the same kind of symbols you use in electricity and magnetism, right? For charge sheet, sigma. For linear charge, lambda, right? And for volumetric charge, rho. Same situation is there over here, but in just, different context. This is for mass. In electricity, magnetism, it is with respect to charges and currents and God knows what, right? So it's a very similar thing. So over here, because it's a sheet-like object, mass per unit area is same. Sigma. So the word that I will be using over here is sigma, not lambda or rho. Okay? Not lambda or rho. I will be using sigma over here. So observe that and see how do we use it. Observe that and see how do we use it. Sigma will be the mass of this body by the area of this body. So m1 by area. What is the area of a semicircle? It is just pi r square by 2. So basically it will become m1 by pi. Radius is half of the side of the square. So it will be basically a square by 4, and this 2 is also there. So from this m1 will become sigma pi a square divided by 8. Sigma pi a square divided by 2 4s are 8. That is the value of mass number 1 of the semicircle. Similarly, do the same thing over here. Sigma will be mass, which is different, by area of the square, which is nothing but just a square. So m2 will be just sigma into a square. Sigma into a square. Awesome. So we found m1, we found m2, we found x1, we found y1, we found x1, sorry, this was x2, my bad. This was x2, not x1. x2, and we found y2. So we found all the coordinates. The only thing remaining is now to find the center of mass. Clearly, from this data and from this data, it is very, very obvious the x coordinate of the center of mass must be 0. So x-wise, there is no shift, there is no need of calculation because both the center of masses are on the y-axis, so there is no x coordinate only. It has to lie on the y-axis. So the only thing is for the y coordinate. So YCOM will be m1 y1 plus m2 y2 upon m1 plus m2. So what is m1? m1 is this one. So sigma pi a square divided by 8 into what is y1? y1 is 2a by 3 pi. 2a by 3 pi plus m2. m2 is sigma a square into y2. y2 is basically minus a by 2. Whole thing divided by total mass. This plus this. So sigma pi a square by 8 plus sigma pi a square by 8 plus sigma a square. That's all. So this is the last part now where we have to just sit and calculate. The best part is sigma, 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 sigma. A square, a square, a square, a square got cancelled. Pi, pi got cancelled. Okay. Then this 2 got cancelled with this, it became 4. So it became a by 4 over here minus a by 2. Just check this out on the top. See if you are getting on the top a by 4 and here you have minus a by 2. So a by 4 minus a by 2. So you have a by 4 minus a by 2. And at the bottom, see what do you have? Pi by 8 plus 1. You have pi by 8 plus 1. What will this be? 1/4 minus half is minus 1/4. So minus a by 4. This thing, take LCM. So it will become pi plus 8 divided by 8. So take cancellations and all those things. Actually, I don't have space, so I'll do it here. Okay. Ignore the mess up in the, writing. So you will just have minus a by pi plus 8. 8 goes on the top, 4 remains below. 4 and 8 cancels, becomes 2. So it will become minus 2a by pi plus 8. Minus 2a by pi plus 8. I missed the 3. Did I miss the 3? Oh, I missed the 3. Oh, ho, ho, ho. Okay, sorry. Let me go back. Okay, so over here, I think there was a and 4 into 3, that was 12. So this was actually a by 12 minus a by 2. Okay, divided by pi by 8 plus 1. So what will this be? A by 12 minus a by 2. So take the LCM. LCM is 12. LCM is basically 12 over here, right? 4 3s are 12, right? Correct. So when you take the LCM as 12, you have to multiply this with 6. So 1 minus 6 will be minus 5. So minus 5a by 12, whole thing divided by, this will be pi plus 8 divided by 8. Okay, so I hope this is fine now. Great. So this will be nothing but minus 5a divided by pi plus 8, and take 8 on the top, take 12 below, 8 cancels with 12 partially. So divide by 4, you will get 2, divide by 4, you will get 3. So this will be minus 10a divided by 3 into pi plus 8. That is what you will get. Minus 10a by 3 into pi plus 8. Just check this out. Yes. Is that right? Everybody with me? Understood? Clear? Yes. Very nice. Very nice. Awesome. So these kind of questions can very rarely come, but you should just have an idea about it. If you have an idea, that's more than enough. Solve this question which came in AIMS 2015. Distance of the center of mass. See, in AIMS only this kind of question comes, so don't worry. You will very rare chance that you might get such a big question in the NEET exam. Okay, but still I solved it for you because just I wanted you to know all the things about center of mass. Okay, so the radius of the base is r, height is this, then how far is the center of mass from the vertex? So this is the cone, this is the cone. The distance of the center of mass of a solid uniform cone from the vertex. So this distance is asked. This is Z0. But usually what is by hearted by you is this distance, and this is h by 4. This is h by 4, right? So how much will be Z0? Z0 will be total height minus h by 4, which is 3h by 4. Which is 3h by 4. Where is it? It is option D. It is basically option D. Very good, very good, very good. Right? So these kind of questions do come in the NEET examination. So I think I had kept some homework questions. Yes, I have kept these homework questions for you. Just try to solve them after the class is over, right? So this is the only part which is there in your current NEET syllabus. Don't have to study anything else. So this is your first question. then try to solve. Oh, that's the only question over here. Okay, great. So I hope you learnt a lot. I hope you have got confidence in center of mass now, because a very small part is now only remaining in NEET. All the other things are gone. Just finding where the center of mass is. Okay, cool guys. So 4 marks pakka guarantee in your pocket from center of mass just because you attended today's class. Practice more and more questions. You will get a lot of confidence. Okay, cool. Take care. Have a great time. Do not forget to leave in the comments which chapter you want next. But I was planning to do rotation. What do you say about it? Rotation and collisions also. So first we'll go with collisions, then we'll go with rotation and then SHM. If you're okay, let me know in the comment section. Waiting for your replies and comments. Bye bye. Hasta la vista. Take care.